The overall goal of this fluorescence in situ hybridization technique is to concisely analyze telomere number and length in C. elegans.
This method can help answer key questions about tumorigenesis, alternative lengthening of telomeres, and cellular senescence.
The main advantage of this technique is that the procedures are concise and the telomeres can be visualized and quantified in less than 24 hours.
Collect the gravid adult worms with a little liquid media, without debris, in a 15 milliliter tube. Now, wash the worms 3 times as follows. Add M9 buffer to a total volume of 15 milliliters. Then, spin the tube down at 300 G for 3 minutes and discard the solution above the pellet of worms. Then, repeat the process. If after the centrifugation the worms are floating, then lighten the brake on the centrifuge. After the third wash, leave the worms with 0.5 milliliters of M9. Then, add 6.5 milliliters of distilled water, 2 milliliters of hyperchlorite, and 1 milliliter of 5 molar potassium hydroxide. Let the worms incubate in this bleaching solution for 3 minutes with 50 RPM of agitation. Then, vortex the worms to shear them open and free their eggs. Under a dissection microscope, look for the released eggs. If they are not released yet, continue the incubation for up to 8 minutes. If the worms are mostly dissolved and the eggs are free, fill the tube to 15 milliliters with M9 and wash the eggs 3 times, just as the worms were washed before. To the washed eggs, with most of the M9 removed, fill the volume to 500 microliters with PBST and then add 500 microliters of 4% PFA. Now, load 40 microliter aliquots of eggs in 2% PFA to the wells of polylysine-coated slides. Then transfer the slides to a humidified chamber and let them incubate for 15 minutes at room temperature. For this protocol, have an aluminum block on dry ice stored at -80 degrees Celsius. Also, have methanol and acetone stored at -20 degrees Celsius. After the fixation step is completed, remove most of the PFA solution from the slides, leaving about 5 microliters. Then, place second polylysine-coated slides over each sample slide so that the 2 coated surfaces stick together, trapping the tissues in the well. If there is excessive fixative, mop it up with a tissue. Now, freeze the slides by placing them on the cold aluminum block for at least 15 minutes. Meanwhile, prepare methanol and acetone baths on ice for the slides. Once the slides are frozen, twist one to freeze-crack the sample. Discard the upper slide and soak the bottom slide in ice-cold methanol for 5 minutes. Do this for all the samples.
Freeze cracking allows for penetration of probes and antibody through the hard eggshell. If the eggs are successfully freeze-cracked, you could see the eggs on both slides.
After at least 5 minutes in methanol, move the slides to cold acetone for 5 minutes. In another 5 minutes, soak the samples in PBST 3 times for 5 minutes per bath. After the PBST washes, the slides may be stored in 100% ethanol at 4 degrees Celsius for several days. To proceed, add 20 microliters of RNA solution to the sample wells and incubate them in a humidified chamber at 37 degrees Celsius for an hour. Next, wash the slides in 2x SSCT twice for 15 minutes per wash. After the 2 washes, add 20 microliters of hybridization solution to the samples and incubate them at 37 degrees Celsius for an hour in a humidified chamber. Meanwhile, prepare the probe. For a double-stranded DNA probe, denature it at 95 degrees Celsius for 5 minutes and then chill it on ice briefly. After an hour, aspirate the hybridization solution and add the probe solution. From this step forward, protect the sample from the light. After adding the probe, cover the samples with glass cover slips. Then, make a humidified chamber on an 80 degrees Celsius heat block. When the heat block has stabilized back to 80 degrees Celsius, place the sample slides in the warmed chamber and let them denature for 3 minutes. Then, incubate all the processed slides in a humidified chamber at 37 degrees Celsius overnight. After the overnight incubation, wash the samples in PBST at room temperature for 5 minutes. In preparation, warm the hybridization solution to 37 degrees Celsius 1 hour before wash. Then load the slides into a jar of hybridization wash solution and incubate them at 37 degrees Celsius for 30 minutes. To remove the hybridization solution, wash the samples with PBST at room temperature for 15 minutes. Do this 3 times. After aspirating off the last PBST wash, add 20 microliters of blocking solution to each sample and incubate them in humidified chambers at room temperature for 1 hour in the dark. Then, aspirate the blocking solution and replace it with FITC conjugated anti-digoxygen antibody solution at 1 to 200. Cover the slides and incubate them at room temperature for 3 hours in the dark. After the antibody stain, wash the samples twice with PBST for 15 minutes per wash in the dark. Next, aspirate the PBST and replace it with 10 microliters of mounting solution containing DAPI. Apply a cover glass and sop up any excess solution. Finally, seal the edges of the cover glass with nail polish and proceed with observing the samples under a fluorescent microscope. Using the PNA probe, the telomeres of animals surviving a telomerase-deficient mutation were observed. In the gonads, the number of telomeres per nucleus is quantifiable. The telomere signal co-localized with a TALT1 signal, supporting the notion that TALT1 is responsible for survivorship without telomerase. The intensity of telomere signal was compared using software. The signal was stronger in the ALT survivors than in the parental strains used to generate the telomerase-deficient mutants.
Don't forget that working with paraformaldehyde and formamide can be extremely hazardous, and precautions such as wearing gloves should always be taken while performing this procedure.